Hi students, today we will discuss some problems on integration KCET level questions. Now the first very important concept is integration of e power x into f of x plus f dash of x whole dx. This is the very important formula in your PUC standards also, and this is very important in KCET. So the answer is e power x into f of x plus c. So by using this formula, we have so many different types of questions are there. Now we can discuss one by one. Now the first question is integration of e power x into sin x minus cos x whole dx. Now coming to this, by seeing this, it is looking like e power x into f of x plus f dash of x. But if you solve this one carefully, integration of e power x into sin x differentiation is cos x, but not minus cos x, right? So I will interchange those values, that minus cos x plus sin x whole dx. So if you observe this one carefully, now if you take this one is f of x, the cos x differentiation is minus sin x and it is followed by minus, so it will become plus sin x. Now it is in the form of integration of e power x into f of x plus f dash of x. So the answer is e power x into minus cos x plus c. So it is nothing but minus e power x into cos x plus c, right? Now move on to the second question. Here is integration of e power x into 1 plus sin x by 1 plus cos x whole dx. This is a very important problem. Here this integration of e power x into 1 plus, the 1 can keep as it is, sin x we can write it as 2 sin x by 2 cos x by 2 divided by 1 plus cos x we can write it as 2 cos square x by 2 whole dx. Now we can split the numerator, integration of e power x into this we can write it as 1 by 2 secant square x by 2 plus the second term 2 sin x by 2 cos x by 2. Here 2 gets cancelled, cos x by 2 cos x by 2 gets cancelled. We will get finally sin x by 2 by cos x by 2 whole dx. So if you observe this one carefully, e power x into sin x by 2 by cos x by 2 we can write it as tan x by 2, and the differentiation of tan x by 2 is 1 by 2 secant square x by 2. So it is now in the form of, this one is nothing but f of x and this whole thing is f dash of x, e power x into f of x plus f dash of x. So it is e power x into tan x by 2 plus c. Okay, right. Now move on to the third question. The same formula, integration of x plus 2 by x plus 4 whole square into e power x dx. Then integration of e power x into, so here x plus 2 whole square they given, I will write this one as x square plus 4x plus 4 numerator, and coming to the denominator I can write this one as x plus 4 whole square only whole dx. So that integration of e power x into, if you split this first two terms, you can keep these two terms as one and the last term. Now if you observe that one carefully, from the first two terms, if I take x common, that is x plus 4 divided by x plus 4 whole square plus 4 by x plus 4 whole square whole dx. Then that is equal to integration of e power x into, if you split the numerator, that is x by x plus 4 plus 4 by x plus 4 whole square whole dx. So now if you observe this, for suppose if you take this one as f of x and this whole thing is nothing but f dash of x, because of we know the formula d by dx of ax plus b by cx plus d equals to AD minus BC by cx plus d whole square. So here a is nothing but 1, d is nothing but 4. So clearly here no b is there, so b is not there, so that we can say it as 0. 0 into 1 is 0, right? So if it is f of x, this is f dash of x, the second term is f dash of x. So the answer is e power x into x by x plus 4 plus c. Okay, now move on to the next question. Question number 4, that is integration of the very important question, 1 by log x minus 1 by log x whole square whole dx. So this is also related to the same formula, but here one thing is you can take log x equals to t, so that if nothing base mentioned we can write it as e, so that we can say this one as x equals to e power t, and the differentiation here is dx equal to e power t into dt, right? So now the question is integration of this dx, I can write it as e power t dt, and integration of this one 1 by t minus 1 by t square into e power t dt. Now if we rewrite this, integration of e power t into this one 1 by t plus minus 1 by t square whole dt. So this one we can take it as f of t, then it is f dash of t. So it is e power t into 1 by t plus c. What about e power t is nothing but x into 1 by log x plus c, right? Now move on to the next question related to integration and the derivatives takes place in the same question. Like this one is very important. So integration of e power tan inverse x into 1 plus x by 1 plus x square whole dx. Now if you observe this question carefully, it is not in the form of e power x into f of x plus f dash of x. So I can just first multiply with e power tan inverse x, that we can write it as e power tan inverse x into 1 plus x into this one e power tan inverse x by 1 plus x square whole dx, right? Now if you observe this one carefully, integration of this one e power tan inverse x into this one, I can write it as the derivative of x plus x into this e power tan inverse x by 1 plus x square, I can write it as e power tan inverse x whole dash, that is derivative of e power tan inverse x dx. So that if you observe this one carefully, f of x into g dash of x plus g of x into f dash of x, that is known as d by dx of the derivative of e power tan inverse x into x. So here clearly integration and the differentiation will eliminate because of the reverse process. So finally what we will get is x into e power tan inverse x plus c. It's a very important model. Observe carefully, right? And coming to the next question, the same type of question, that is integration of x plus sin x by 1 plus cos x whole dx. Same type of question, like integration derivative question, that is integration of this one x plus sin x, we can write it as 2 sin x by 2 cos x by 2 divided by 1 plus cos x is nothing but 2 cos square x by 2 whole dx. Now can split this numerator, so we will get here as x into 1 by 2 secant square x by 2 plus, here 2 gets cancelled and 1 cos from the numerator and cos from the denominator will get cancelled. Finally you will get tan x by 2 whole dx. So if nothing is there, I can write this one as tan x by 2 into 1, so that integration of this one x into the derivative of tan x by 2 plus this one tan x by 2 into the derivative of x. So this is also same derivative of u into v formula, f of x into derivative of g of x plus g of x into the derivative of f of x, so that we can write this one as d by dx of x into tan x by 2. So here clearly integration differentiation both will get eliminated, so that what will get finally x into tan x by 2 plus c. And coming to the next question, integration of root x by x plus 1 dx. Now it is integration of root x by, clearly denominator we have x and the numerator is root x. We can't make the root x as x, but we can make the x as in terms of root x, that is 1 plus, I can write this one as root x whole square dx. So if I take root x equals to t and then x equals to t square, if it is x equal to t square, the derivative equal to 2t dt, dx equal to 2t dt, right? So that integration of root x is nothing but t and dx is nothing but 2t dt divided by this one 1 plus t square. So we can add 2 outside, integration of t square by 1 plus t square dt, right? So that we can add 1, subtract 1 in the numerator. So we can split the numerator. So 1 plus t square by 1 plus t square minus 1 by 1 plus t square whole dt. So 1 plus t square gets cancelled, so that it is 1 minus 1 by 1 plus t square whole dt. So this is 2 into integration of 1 is t minus integration of 1 by 1 plus t square is tan inverse t plus c. So that is equal to 2 into t, here is nothing but root x minus tan inverse of root x plus c. So very interesting question, right? Now move on to the next question, that is integration of 1 minus x square by 1 plus x square dx. So in case of this type of questions, numerator highest degree and the denominator highest degree both are same. We can divide first plus x square and minus x square plus 1, and if it is the quotient is minus 1, then we can write this one as minus x square minus 1. So they get plus, and here also will get plus, minus x square plus x square will get cancelled, and the remainder what will get is 2. So this 1 minus x square by 1 plus x square, we can write it as minus 1 plus 2 by 1 plus x square. If you do integration on both sides, integration dx, integration dx, then integration of minus 1 is minus x plus 2 constant. This one we can write it as tan inverse x plus c. Very interesting question. Next, integration of x square plus 1 by x power 4 plus x square plus 1 dx. Now in this type of questions, if you see the denominator, the highest degree is x power 4. In this type of all the questions, similar questions, we can divide the numerator and denominator with x square to make that x power 4 as x square, so that the numerator will become 1 plus 1 by x square whole dx divided by, and this one is x square plus 1 plus 1 by x square you will get. Now this is integration of 1 plus 1 by x square whole dx divided by, now we can write in the order x square plus 1 by x square, that plus 1 I can write as minus 2 plus 3, minus 2 plus 3. So if you observe the first three terms in the denominator, observe carefully, the numerator is 1 plus 1 by x square whole dx divided by, this one I can write it as x minus 1 by x whole square plus root 3 whole square. So clearly here x minus 1 by x equal to t, then the differentiation of x minus 1 by x is 1 plus 1 by x square dx equal to dt. So that numerator will become dt and the denominator will become t square plus root 3 whole square, so that it is 1 by a tan inverse of x by a. Let's see, here t is what? X minus 1 by x, 1 by 3 tan inverse of x minus 1 by x by root 3 plus c. Right. Now coming to the next question, integration of root over 1 plus secant x whole dx. So this type of questions are very rare questions, but is a very important question, and we can convert this one into half angles. Now see how we are going to convert this question as integration of root over 1 plus secant x, we can write it as 1 by cos x whole dx, that is equals to integration of root over, if you take cos x LCM, then the numerator will become 1 plus cos x whole dx, then this integration of that numerator 2 cos square x by 2 by that cos x in the denominator I will write as 1 minus 2 sin square x by 2 whole dx. Now integration of root over the numerator 2 cos square x by 2 can keep as it is divided by, from this denominator I can take 2 common, so that it is 1 by 2 minus sin square x by 2 whole dx. Here 2 gets cancelled, so that the numerator will become root over cos square x by 2, which we can write it as cos x by 2 by root of 1 by 2 is 1 by root 2 whole square minus this one sin x by 2 whole square whole dx. So that I can write this one as sin x by 2 equal to t, the differentiation is cos x by 2 into 1 by 2 dx equal to dt. So cos x by 2 into dx we can write it as 2 dt, cos x by 2 into dx we can write it as 2 into dt. So integration of the numerator will become 2 into dt by root over 1 by root 2 whole square minus t square. So it is in the form of integration of dx by root over a square minus x square, so that it is sine inverse of t by 1 by root 2 plus c. So the 2 times of sine inverse of root 2 t plus c. So it is 2 into sine inverse of root 2 times of t, here is sin x by 2 plus c. Now the next question is, and this is also very important question, that is dx by 1 plus 3 sine square x, and the very important question. So we can read this question. Yes, integration of dx by, so here 1 is there and 3 sine square x by 2 is there, so that 1 I can write it as cos square x plus sine square x plus 3 sine square x as it is. So integration of dx by this one cos square x plus 4 sine square x, right? From this I can take 4 cos square x common, so that here I will get 1 by 4 plus tan square x. So 1 by 4 constant outside, and denominator cos square x is there. We can write that one as a secant square x into dx divided by this one 1 by 2 whole square plus tan x whole square. So tan x equal to t. In case of tan x equal to t, secant square x dx equal to what? dt. So 1 by 4 integration of dt by 1 by 2 whole square plus t square. So if it is this, it is in the form of 1 by a square plus x square, so that is 1 by a tan inverse of x by a t by 1 by 2 plus c. 2 1s are 2 2's gets cancelled, 1 by 2 tan inverse of 2t plus c. Here t is tan x, so 1 by 2 tan inverse of 2 tan x plus c, right? Now the same similar type of question, one question I will give you, you can solve and comment the answer, right? That is integration of sin 2x by sin square x plus 2 cos square x whole dx. Yes, same similar type of question, you can solve it and you can comment the answer. Okay, thank you.